Thank you, Krish. So folks, there's two things we're going to talk about. As Krish pointed out in the earlier slide, we'll show you how our feeds and speeds are computed when we use load from file. We'll talk about how it's done in using the calculator in here. And then we'll also show you how we use feeds and speeds for our multi-axis motions in here as well. So I'm going to give you a quick run through of both of these in here for the feeds and speeds. So what I'm going to do here is I'm going to bring in a spreadsheet for you folks so you can take a look at it. And also we'll basically based on how the calculations are done. So as Krish pointed out, for computing the spindle RPM, we use the surface speed in inches per minute, and in the denominator we're going to use pi times the tool diameter. These are the variables in here. Now the surface speed in the XML file or the materials file, you're going to be defining it in feet per minute. So if you're working in inch units, it's in feet per minute, so we automatically take that times 12. And then in the denominator you have the value of pi times the tool diameter. So if you actually specify your surface speed and the tool diameter, your computed spindle RPM is 3,055 RPM for a half an inch tool with a surface speed of 400. And that's exactly also what you're seeing over here. If you specify the same parameters for the feet per tooth and the surface speed, you're seeing that you're getting a spindle RPM of 3,055 and a cut feet of 61, exactly what I showed you here in the spreadsheet as well. So I'm going to put this over on the side here so you can actually see them, compare them side by side right there. So that's the exact value what you're seeing here in these two dialogues as you see it. So the surface speed, the spindle speed is computed using this math right here. Now how do we compute the feed rate? So we take the variables, the feet per tooth. Now this is your feet per tooth is basically set, it's being read from your feeds and speeds file, which is the property of your cutter. And then we also take into account the number of flutes and times the spindle RPM that was computed. So the feed rate here is basically, if you have your spindle RPM as 3,055, your feed per tooth is 0.01, and then the number of flutes is 2, your computed feed rate is going to be 61, and that's exactly what you're seeing here in the calculator. So I just wanted to show you what is the math behind it and how our feeds and speeds calculator computes these parameters, and you can use this as a reference, or you can come up with your own if you have a if you want to use your own way of computing, you can always feed those parameters in here, and then you can also have the XML file, the feeds and speeds file updated to your application needs. Now this is how we use it for 2 and 3 axis operations, and also if you're using multi-axis operations and not programming inverse time feed rate, we use the same calculator in here as well for programming multi-axis as well. But if your machines can handle inverse time feed rates like G94 or G93 to toggle on an inverse time feed rate, and the G94 to toggle off the inverse time feed rate in here, we could be using inverse time feed rates to be able to program feed rates for 4 axis, and for that I'm going to give you a quick example in here as well and how that is done. So as Krish gave you the math that's behind the computation of inverse time feed rate in here, I'm going to show you with an example of how the inverse time feed rate is computed and how it's done in the post processor. So in your post processor, depending on the type of post processor you're working with or machine tool you're working with, you would want to go under the feed rate section, and you would want to select the option to output inverse time feed rates. And then typically for the inverse time feed rate, the code to toggle it on is a G93, and the code to toggle it off is a G94. So as you specify the G93 and G94 options in here, the system will now use the inverse time feed rate math, the computation, to compute the feed rates for multi-axis motion, and this is applicable to both 4 and 5 axis continuous operations. They're not applicable to indexed operations, only continuous or simultaneous 4 and 5 axis operations. So you will see a feed rate value that's being computed and output for each of the lines of the code in your posted output file. So you can toggle it on by going into the inverse time feed rate option, and this is available in Expert, Pro, and Premium configurations. Now all the other options we talked about are available right from standard configuration of our products as well. Now while we're on the post-processor page, I wanted to talk about a few other things in here. This is where you can also specify your high values and the low values for your feed rates, depending on what is the lowest feed rate you'd want to set, and the high value is the highest value that your machine can handle for your feed rates. So what this means is if your program feed rate is higher than the high value that is set in the post processor, then the posted output will be capped to the high value that's defined in the post processor. So for example, if your program feed rate is 325 inches per minute and the high value in the post is set to 300, your posted output will show a feed rate of 300 and not 325. So that's what the high and the low values are, they use to basically set the highest feed rate and the lowest feed rate values, the range for your machine tool. Now, certain machine tools expect the feed rates to be in units per second. This could be in inches per second or millimeters per second. So in your machining operations, you would be establishing your feed rates as units per minute. It could be inches per minute or inches per second. Now over here, you have the option called scale factor, where you can scale the output to units per second. So if you put in a value of 0.016667, which is basically scaling it from per minute to per second, the posted output will be reflected with the change. Now, one of the machine tools that I'm familiar with that uses units per second is multicam. There are several other machine tools which also expect the feed rates to be in inches per second. So you do that scaling in the post processor. However, when you're programming the tool paths, you're still defining your feed rates in inches per minute, or if you're working in metric units, you'll be defining it in millimeters per minute. And the scale factor in here will take care of the conversion from your inches per minute to inches per second. And this is set right in here under the feed rate tab. Now, very similar to how we have the feed rates for the high and the low values, we also have a option for the spindle where you can set the high value and the low value depending on what your machine tool is capable of. So certain machine tools can go more close to 20,000 RPM or 30,000 RPM. Again, it depends on the machine tools. You can set the high value for your spindle right in here. And this can be set. So if your programmed spindle RPM is higher than the high value, your posted code will use the high value to cap it to the high value in the posted code. So make sure that you update your post processor to reflect what's set on your machine, what the machine tool is capable of for your high and the low values. And also you can specify your spindle direction in here, which could be M3 or MO3 for clockwise and counterclockwise rotations. Now in turning, we also have the constant surface speed and constant rotational speed. Those codes can be set right in here for the spindle, and also for the feed rates you can specify the units per minute and units per revolution code as well for turning module, which is typically used on CNC lathes and turning centers. So folks, with this, I've given you an overview of the feeds and speeds settings in our CAM product. If you do have any questions, we'll be more than happy to answer them for you. And
just one other thing. There were some questions about the blog. I think most people are not familiar with the blog. Can you just mosey on over to the blog and the two articles that I referenced in the question panels? Thank you.
Absolutely. So to access our blog, the easiest way for you guys, folks, to do it is go to VisualCam or RhinoCam or VisualCam for SolidWorks or LibreCam from the menu, and then click on website. So this will direct you to Mexoft's website. And as you scroll all the way down to towards the bottom, the footer, you can click on Mexoft blog, and it'll directly take you into our blog page. And as Joe pointed out, we have two recent articles. If you search under recent articles, you see that there's one about the milling feeds and speeds calculator, and you can read about it. And we also have another blog article on how to customize the material data for feeds and speeds. And this blog article have been put together by my colleague Don LaCourse. And you're welcome to read about it. And if you have any questions, please let us know. And again, to access the blog article, you can go to our website, mexsoft.com, and then select the blog link from the bottom of the page, and they should take you directly to the recent articles and the blog articles.